Hello everyone, I'm going to show you the tutorial how to set up Stable Diffusion C++ on my Linux box and on Linux because I have Linux. And if this video would become popular and if you want to know how to set it up on Windows, let me know. Like, subscribe and all this stuff, and put the comment you want it for Windows. But for now, because I'm using Linux, I am going to show you how to do this thing on Linux. Let me get the Chrome Windows. I guess we are going to go to GitHub / I don't know where is it. Stable Diffusion C++. Stable Diffusion C++. Hopefully
StableDiffusion.cpp.
it's gonna search. Yeah, I think I get it from here. We'll go here and then copy it, and let's go to project. Let's make a directory tutorial. I don't know, I'll delete it anyways. So tutorials and git clone. Let's make it slightly bigger, recursive, and we are going to put this link here to clone the repository. And let's make Emacs, open Emacs, and read the instruction. So there is a readme. We can read the instruction also from the web page. So let's do it from the web page. So there is features. Anyways, what is Stable Diffusion? It's tool for generating images using artificial intelligence, AI image generation tool, similar as popular one, DALL-E or Midjourney. And you can do this thing on your computer without using cloud locally. With this thing you can do if you have potato computer, just using CPU. You do not need GPU. Clone, go to directory, then because I did clone recursive, I don't need to do this thing. Oh yeah, and they said that if you didn't do this thing, you can do it this way. Anyways, we are not going to download weights for now, but building from scratch, and this is instruction how to build for your potato computer. If you do not have GPU, you just build it like this. But because I have GPU, I am going to build using CUDA, and you need to install NVIDIA CUDA toolkit by running this command for my Ubuntu. So yeah, it did say it's already installed, and let me run auto remove as well, just to keep things clean. So we did run this thing. Now we need to run this command. So this command, if you have NVIDIA video card and you can use CUDA, I'm pretty sure they will update it for using not BLAS, because our version, which is for LLMs like ChatGPT, they are already updated it. So maybe they will update this thing as well to just using directly CUDA without QBLAS. Anyways, so let's do make dir build. Oh, wait a second, we need to go inside the directory. Make dir build, cd build, cmake. So instead of doing this cmake, we need to do this cmake. So this one will include kublas, which is kudu support. And do this line. So probably I need to put this keyboard other side on the screen. Put it here. Okay, it's built, and now we can run it. So to run this thing, we need weights. So we need to download weights. There is a link on this page where we can download weights. It said, like, for example, Stable Diffusion 2.1 can be downloaded from here. And you know, there is a version which is so you just go to this link, right? So there is a version which is supposed to be better. It's called XL, SDXL, Stable Diffusion XL, and they have base version, SDXL Turbo. Where is the base version? Stable XL. Yeah, here is it. There is a base version, and apparently it's better version. You can download it from here, files and versions, and you need to have a file which is safe tensors extensions. I already downloaded it, but to download it, you click here and it downloads. Let's download it. So it's going to take 1 minute anyways. And there is another one what you need to download, and this is also in instructions. SDXL have the problem which generates black screens, and it's due to non-issue, and you need to download the patch. So you can okay, I click wrong button. So you can download patch from here, and same thing. Where is the download button? Here, but you can still download it, and we just download it. So I have it already in my download directory. I forgot to delete it. Anyways, so now you can run it, and there is instruction, simple instruction, for example, how to run text to image version, and we can just do it like this. So we can put it here, and we need to specify the model. So it's in my download directory, and it's I do not remember the name, but we can check it out. So it's a SDXL base, SDXL base, and we can just run it. It will complain and say it's black screen, but I'll show you so you would know what to see. So it says it looks like you are using SDXL model. If you're just completely black, you need to download this thing, and then anyways, let's see if it's black. It's probably black. Yeah, it's a black image. So what you can do, add this thing here, -y. Okay, -y, download, and the second file what we downloaded is SDXL_y, SDXL, SDXL_y, and there is a two files because it doesn't matter which one to use. Just they actually different. I did not know why they different, but anyways, you're not happy. Why? Oh, dash. I'm sorry. So I need to put dash dash here. Okay, open output.png. It's a black screen. I had suspicion they're a little bit different, and probably they are different. So let's see if second one is going to work better. The one which I just downloaded using the instruction. Yep, so we've got the image of the cat, and now it's fun to make the model to work, right? There is a bunch of parameters here, and one of the important parameters is config scale, and I did not play with this thing, denoising parameter. Probably it's also important. So sampling method is definitely important, a number of steps. So I was playing around with these 3 parameters to make it work. Let me show you some of my results. Let's do this thing, for example. I already downloaded, and the weights are here. Let me see with the base model what I have. This what I have with my base model, and I can put the things what I just downloaded, right? Download SDXL base, and for Y we need to put download SDXL space like this, and I put this prompt. This is the prompt, and also I put the negative prompt somewhere with -n. I'm not seeing -n. Yeah, here we go. This is the start of the negative prompt. It goes all the way to the here, and then I put config scale 8 and sampling method. So there is a bunch of experience. This is the seed, number of images to generate, number of steps, and image size, and output. Let's put jet pilot. So here we go. This is the version of Stable Diffusion what I just built in this tutorial, and this is the downloaded version of the weights. This is the patch for weights, and you saw like it's if you did like a lovely cat, it's going to produce quite unpredictable result. But here we go. So -1 means random seed, and you can put like any number here to make repeatable results. With random seed, it's going to be more or less random image, of course, in the frame of the prompt and negative prompt. What I learned, scale is higher numbers means it's going to be closer to the prompt. Lower numbers, it's going to have more flexibility to deviate from the prompt. Sampling methods, quite important thing. There is a list of them, and you can just experiment with them. I found this one is working well. Euler _A also working well, and there is LCM is kind of interesting results, and you can try all of them. So this is the fun with generating images locally. So this is the seed, and this is the batch number. Usually I use 3, and number of steps, more steps is longer generation, but actually not necessary better results. You still have to find the sweet spot for steps. So I found the 30 is pretty good for this model and like these settings. And so okay, so we have 3 images. Jetpilot, open jetpilot.png. So, and we've got this result this time. So this is the one of the images, this is another one, this is the third one. It's completely random. I didn't know I'll get this thing. I kind of knew it's going to be a little bit have like a retro style things, but I showed you it's everything built from scratch, downloaded from internet. It's like the binary and stuff. This is the StableDiffusion.cpp, and I really like it. It's running on C++, doesn't need any Python AI shenanigan around what usually AI stuff needed, like I don't know, it's so hard, PyTorch and all these dependencies and Anaconda, Miniconda, Conda, nothing. Like you just need to have Git, C++, and the dependency. What I meant to, if you have CUDA and want to use GPU, and you can run it on your potato computer if you want without GPU, and it will run on CPU. Great tool, great project. Probably I should start it. You know, let's put the star on this thing. I didn't do this thing before. It's such a great time to be alive, you know. Amazing. I'm playing full day today. I was playing, I should do preparation for technical interview, and instead I was playing around with this stuff. Can show all this generation images, what I generated, anime style. It's like all these experiments with parameters, just to tune parameters to make it work. All these images, all these images. This one, look at this, it's amazing how beautiful it is. Or this robot, wow. And it's completely free. You can do it even on your potato computer. And this one I was practicing with just the base model. Yeah, let me show you another thing what I found. It is Civit AI. So civitai.com, you can download models. So the images what is here, anime style images, it's on the model which I found here, and I just looked at the image. I like the how it looks like, and I can look here and it says like it's this model, so I can click here and download it, and I just click on download. I need to log in, but download apparently is free, so you can download the model and use it. And also there is a bunch of parameters shown here, how image was generated, so you can use it as a base. So this is prompt, this is like a scale, steps, and sampler. So this is 1, 2, 3 parameters what I was playing around to tune stuff, and you can just use them, and it would be good starting point for you. This is the end of the tutorial. Hopefully you enjoyed it, and again, if you want to see how to do this thing on Windows, let me know, and if it will get enough traction, I'll do tutorial for Windows. Thank you for watching, and hopefully see you next time. Bye.